Welcome, everyone, to this deep dive for the bite size.
Tech News TLDR.
Yeah, exactly. The bite size tech news TLDR. We're jumping right in today because we have a topic that fundamentally challenges how every single modern business operates under the hood.
It really does.
If you are joining us right now, you know the mission of our TLDR format. We cut straight through the conversational fluff.
Bypass the noise.
Right, bypass the noise and deliver the absolute bottom line. You are busy, your time is incredibly valuable, and our goal in this deep dive is to extract the immediate security and productivity impacts of the news you need to know.
And today's topic is, well, it's a massive shift.
It's huge. Today, we are looking at a radical new concept gaining a lot of traction in the industry right now, and it's called company as code.
Company as code.
Yeah. This is an entirely different paradigm for organizational architecture. It was brought into focus recently by Daniel Rothman in a fascinating article and a YouTube video analysis titled Company as Code, The Future of Organizational Management.
It is genuinely a transformative concept.
Right.
What we are examining today isn't just, a minor workflow tweak.
Right.
Or some new sauce tool to just slap onto your existing stack. It is a complete reimagining of organizational architecture from the ground up.
Ground up.
Yeah. Moving away from legacy administrative methods and actually applying pure software engineering principles to the the structural nature of a business.
Okay, let's unpack this because the central irony here is practically glaring once you finally see it.
Oh, absolutely.
We live in this incredible age of dynamic digital systems. We have interconnected real-time tools for literally everything.
Everything from how we deploy microservices.
Using Kubernetes clusters, exactly, to how we track global supply chains with automated self-healing logistics networks. We have all this dynamic power, but when it comes to the actual structure of our own companies,
it falls apart.
It totally falls apart. The rules, the reporting lines, the fundamental DNA of the business. We are entirely reliant on digital paper.
Digital paper.
We are building the future, but the blueprints for the companies doing the building are stuck in this bureaucratic past.
That irony right there is the perfect starting point for understanding why this matters to your daily workflow. Think about the modern high-tech software company.
Okay.
It's a brand new, state-of-the-art supercar.
Nice.
It has aerodynamic design, massive horsepower, and the ability to pivot instantly in the market.
Sounds expensive.
Very expensive. But there is a catch. This beautiful supercar is running on an old, clunky steam engine.
Steam engine.
Right. The supercar represents our product output and our dynamic software tools.
Right. The stuff we sell.
Exactly. While the steam engine represents our organizational management, it's static, it's slow, and it's completely disconnected from the high-speed reality of the business it is supposed to be powering.
So to push back on that just a bit, are the things really that archaic? I mean, most modern enterprises aren't using literal paper anymore.
No, of course not.
Or even basic PDFs. They have these heavy-duty HR platforms. They have Workday, Bamboo HR, Active Directory. Are those systems really equivalent to a steam engine?
They absolutely are. And here's why. Think about how those systems actually operate under the hood.
Okay.
When a company moves away from physical filing cabinets, they usually just digitize the medium.
Meaning they put it on a screen?
Yes. They digitize the medium, but they do not digitize the utility. A record in an HR platform is ultimately just a digital filing cabinet. It is flat. It's static.
Right.
It might be stored in a cloud database somewhere, sure, but it represents what we call a lonely island of documents.
A lonely island, meaning it's isolated from the actual day-to-day operations.
Exactly. Think about what an island implies. It is entirely cut off from the mainland. In this context, the mainland is the real-time, pulsing flow of operational data moving through the business.
So the GitHub commits.
The GitHub commits, the AWS deployments, the live customer databases. Because these static organizational documents and HR records are stuck on an island, you cannot interact with them in any programmatic way.
You can't code against them.
No. You can't dynamically run tests against them. You can't automatically link an HR policy change to a live operational system constraint.
They just sit there.
They just sit there on a server, gathering digital dust, until a human explicitly queries them. and usually through a really clunky user interface.
This clicks into place perfectly when you look at the triggering event that kicked off this whole company as code concept for Rothman.
Yes, the origin story.
Right. The catalyst wasn't some theoretical whiteboard session. It wasn't an academic exercise. It was a security audit.
The dreaded audit.
Now, if you are listening to this and you've ever been through a SOC2 Type 2 audit or an ISO 2701 certification.
My sympathies.
Right. It is usually an all-hands-on-deck, highly stressful nightmare. It's the moment where the supercar realizes it's stuck with the steam engine.
Precisely. During a high-stakes audit, auditors are asking dynamic, complex questions. They don't just want to see your employee handbook.
No, they don't care about the PDF.
They want proof, real proof. They ask, show me the exact onboarding path for every back-end engineer who was granted access to the production database in the last 6 months.
Oh, boy.
And prove that each one of them completed mandatory security training before their access token was actually provisioned.
And what happens in a normal company when that question gets asked?
Panic. Total panic.
Complete panic. Because to answer that dynamic question, the company has to frantically search through static, isolated documents.
It's a scavenger hunt.
Exactly. An HR manager exports a CSV from Workday. An engineering manager takes a bunch of screenshots of GitHub permissions. An IT admin is pulling logs from Okta.
Just dumping it all in a folder.
Right. And then some poor compliance officer spends 2 weeks trying to stitch all these disparate static data points together in a massive Excel spreadsheet just to prove a negative to an auditor.
The structural lag exists because our organizational tools never evolved to become unified and programmatic.
And here's the bottom line for your productivity. This document disconnect has a massive tangible cost.
Massive.
We are talking about hundreds of extra person hours spent just to get through a single compliance audit. Think about your own day-to-day workflow.
Think about your sprint cycles.
Yeah. If you are paying top-tier, highly specialized engineering talent to build incredible software, but then forcing them to act as manual data gatherers and screenshot takers for days on end.
You're hemorrhaging money.
You're hemorrhaging money. Those are hours that should have been spent building, innovating, driving the business forward. The productivity drain is staggering.
You are paying a massive operational penalty every single time you have to bridge the gap between your static policies and your dynamic reality.
The manual bridge.
Yes. The island of documents isn't just lonely, it is incredibly expensive to maintain.
So what does this all mean?
How do we fix it?
Exactly. If we know the steam engine is failing us, and we know the lonely island of documents is costing us hundreds of hours in lost productivity, how do we fix it? We need a paradigm shift.
We do.
We need to move from the problem directly to Rothman's proposed solution, which is the complete adoption of company as code.
The core of this solution is taking that static, isolated island of documents and turning it into a living, breathing, programmatic model of the entire organization.
A living model.
Yes, we are taking the exact same principles of modern software engineering, specifically DevOps and infrastructure as code, and applying them to human capital and organizational management.
Okay.
The primary feature of this new system is that it establishes a version-controlled, single source of truth.
Right. So instead of a Git repository that holds the code for your web application, you have a Git repository that holds the code for your company.
Exactly.
Every role, every reporting structure, every internal policy is written in code.
Written in code. And just like a software repository tracks every single change made to a code base, a company's code system tracks every change to the company's structure.
It has a commit history.
Yes, but it goes beyond just tracking history.
Yeah.
Because it is code, you can query it programmatically.
This is where we shift from using a paper map to using live GPS.
Oh, that's a great analogy.
Think about how we used to navigate with those big folded paper maps. A paper map is static. It doesn't know where you are.
You have to figure that out yourself.
Right. It doesn't know if there is traffic ahead or if a road is closed for construction. You have to manually find your location, manually plot your course, and manually adjust if you hit a detour.
Very slow. Very manual.
That is exactly how we currently manage our organizations using static documents and org charts. They are out of date the second they are printed.
What's fascinating here is how perfectly that analogy encapsulates the shift from manual to automated. A live GPS on your phone is instant. It is fully integrated. It knows your exact location. It processes real-time telemetry about traffic and road closures. And it dynamically reroutes you.
It adapts.
It adapts instantly. If a new hire walks through the door or a security policy is updated, a company as code architecture instantly propagates that change across the entire system.
And the real-world implications of this for your workflow are massive. Let's go back to that auditor.
The auditor asking the difficult questions.
Exactly. Instead of the fire drill where everyone is frantically taking screenshots of Okta and Jira, the auditor asks for proof of compliance.
And in the live GPS world,
In the company's code world, you don't dig, you just run a query.
you F the system.
You execute a command against your company's state file that says, return a list of all engineering roles and verify their multi-factor authentication compliance status. Boom.
Done in 3 seconds.
Done in 3 seconds.
You are shifting from a state of constant manual retroactive discovery to a state of instant programmatic verification.
Proving things instantly.
Yes. But the implications go much further than just saving time on audits. It introduces the concept of a sandbox environment for your entire company's operational structure.
Okay, I have to stop you there. Because when I hear coding the company structure, my immediate thought is rigid bureaucracy.
Sure.
If every human action or organizational change requires a code commit, aren't we just creating a massive bottleneck? How does a company stay agile if you have to write code just to change someone's title or give them access to a new Slack channel?
That is the most common and, frankly, the most valid skepticism surrounding this model.
That sounds slow.
It sounds slow if you don't understand modern deployments. You have to look at how modern code deployment actually works. We aren't talking about writing custom Python scripts for every little change.
Okay.
We are talking about declarative systems managed by continuous integration pipelines. The agility actually increases because of that sandbox concept.
Let's walk through that. How does an organizational sandbox actually increase agility?
So we take the standard software sandbox concept, a safe, isolated testing environment, but instead of spinning up a test server, we are spinning up a mathematical clone of the entire corporate reporting structure.
A clone of the company.
Yes. Let's say you are the CEO and you are considering a massive reorganization. You want to merge the marketing and sales departments.
Always a fun time.
Always a disaster. Today, you draft a memo, you move some boxes around on a PowerPoint slide, you announce it at an all-hands, and then you spend the next 6 months dealing with the chaotic fallout of broken permissions, misaligned reporting structures, and compliance violations because the sales team suddenly lost access to the CRM.
Right. It's the move fast and break things approach, except applied to human beings, which usually ends in disaster.
Exactly. But with company as code, you create a branch of your company repository. You write the code for the new merge department in a staging environment.
Like a dev branch.
Exactly. You run automated tests against it. The system analyzes the proposed changes and instantly flags the conflicts.
Before it happens.
Yes. It tells you, warning, by moving the marketing team under the VP of Sales, 40 employees will lose their specialized access to the analytics database due to a conflicting security policy on the sales node.
That is wild. You can see the exact ripple effects of a reorg in a safe sandbox before you ever hit deploy on your company's reality.
You are applying the scientific method to corporate restructuring. You form a hypothesis, you test it in the staging environment, you observe the telemetry, and then you push to production only when the tests pass. It completely removes the friction and the blind guesswork from organizational evolution.
Okay, conceptually, I am totally sold. This sounds amazing. But as someone who actually has to think about the logistics of building this, I am wondering what the engine looks like under the hood.
The actual mechanics.
Yeah, what does this code actually look like? Are we talking about hundreds of thousands of lines of C++? We need to get into the technical blueprint and the immediate security impacts.
The foundation of this entire architecture relies on something called a Declarative Domain Specific Language, or a DSL.
A DSL.
Yes. We need to clearly differentiate this from imperative programming. In an imperative approach, which is how most legacy IT scripts work, you have to write out the exact step-by-step instructions on how to achieve a goal.
Tell it exactly what to do.
Right. You have to tell the computer, log into this server, open this database, locate this user row, change this value from false to true, save, and exit. It is micromanagement.
And it breaks incredibly easily. If a server IP address changes, the whole script fails.
Exactly. But in a declarative language, you simply focus on the what. You declare the desired end state.
The end state.
You say, this user must have database access. You don't care how the system makes it happen. The underlying infrastructure engine figures out the step-by-step mechanics to ensure reality matches your declaration.
The best comparison here is to cloud infrastructure tools, specifically Terraform.
Perfect comparison.
If you manage cloud servers today, you don't click around in an AWS dashboard manually spinning up EC2 instances. You write a Terraform configuration file.
You declare your state.
You declare your end state. You write a block of code that says, I want 3 servers behind a load balancer, configured exactly like this. Terraform reads that file, talks to the AWS APIs, and builds exactly what you ask for.
It makes reality match the code.
Yes, Company as Code uses that exact same philosophy, but instead of cloud servers, you are configuring human roles, reporting structures, and internal policies.
It is the architectural blueprint approach applied to governance. Let's actually walk through what this implementation process looks like in practice, because there are 3 distinct steps to building this organizational code base.
Okay, let's do it. Step 1 is defining the fundamental building blocks, which are the roles.
The roles, yes.
You don't start by importing a list of employees. You start by defining the structural shape of the organization.
Right. Imagine writing a block of YAML or JSON code. You are creating a machine-readable template. You might write something like kind, role, name, senior backend engineer. Yeah. And within that block, you declare the properties of that role. You declare what GitHub repositories it has read and write access to. You declare what Slack channels it auto-joins.
What security policies govern it.
Exactly. You are creating a crystal clear programmatic definition that exists independently of the person who will eventually hold that job.
You are building the empty seats on the bus before you let the passengers on.
Precisely. You establish a standardized, unshakable foundation. Once you have those defined role templates, you move to step 2, which is populating that structure with actual identities.
So this is where Alice Smith comes in.
Yes, Alice Smith.
You create an identity block for Alice. Kind. Identity, name, Alice Smith. And then you assign her to the predefined template. You write a relationship mapping that says Alice Smith occupies the role of senior backend engineer.
And this is where the magic happens. Because you assigned her to that declarative role, the system takes over.
The engine revs up.
Yes. The system automatically reaches out via API to your identity provider like Okta and provisions her accounts. It reaches out to GitHub and sets her permissions. It reaches out to Slack and adds her to the channels.
Wow.
All because you declared her relationship to the role in the code base. You are literally building the company's org chart piece by piece, writing lines of code that have actual operational weight.
Okay, but who maintains this? If Alice gets promoted to engineering manager, is the HR department supposed to open a terminal window, pull down the Git repository, edit a YAML file, and submit a pull request to the engineering team?
That would be a disaster.
Because I can tell you right now, that is never going to happen in a million years.
And that is a crucial point.
Wow.
We will get to how we solve the user interface problem in a moment, because you were absolutely right. HR is not going to learn Git.
No way.
But before we solve the UI, we have to look at step 3, which is the codification of policies. This is truly where the system shows its teeth and delivers the ultimate security value.
Okay, you have your roles, you have your people assigned to those roles. Now you layer in the governance.
The rules.
Let's talk about a specific hard requirement. Multi-factor authentication, or MFA. In a normal company, this is a written policy in a PDF handbook somewhere. You just hope people follow it, and IT periodically runs scripts to try and catch people who turned it off.
In Company as Code, it is a declarative rule. You write a block of code that says, requirement, MFA equals true.
Simple.
You apply that requirement globally or to specific high-risk roles. But you don't stop there. You take that internal MSA requirement and you map it directly in the code to the external compliance requirement it is supposed to satisfy.
So you explicitly write a line that says, this MFA rule satisfies ISO 27001 Control A.9.4.2.
Yes. And here is the immediate security impact for any CISO listening to this right now. Because you have explicitly linked the internal policy to the external framework inside the code base, the audit trail is baked into the company's DNA.
It's just there.
It is a fundamental property of the system.
Compliance by default.
Exactly. If the code declares that a senior backend engineer must have MFA active to satisfy ISO compliance, and Alice Smith is assigned that role, the system's continuous integration pipeline will constantly check her status.
It's always watching.
Always checking state. If Alice somehow manages to turn off her MFA in Okta, the state of the real world no longer matches the declared state in the code.
The system recognizes a drift in state.
Yes, and because it is declarative, The system can automatically take action. It can instantly revoke her access to the production databases until the MFA is toggled back on.
That is powerful.
You have transformed a retroactive manual checking process into a proactive, continuous state of guaranteed, mathematically provable compliance.
If we connect this to the bigger picture, though, we have to return to my earlier objection.
The UI problem.
Exactly. All of these lines of declarative code, all of these beautifully automated state reconciliation loops, they're incredibly powerful, but having a brilliant code base is totally useless if the people who actually run the business cannot interact with it. The CEO is not writing Terraform scripts. The head of HR is not opening pull requests.
Right. A purely code-based system relying on command line interfaces creates a massive barrier to entry. Which brings us to the core challenge of cross-company viability.
How do we actually use this thing?
Exactly. How do we take this highly technical programmatic engine and make it usable for the entire organization?
The answer lies in what happens to all that code after you write it. It doesn't just sit in a flat text file. When you commit this code, it compiles into a specific kind of back-end architecture known as a graph model.
Yes, a graph model.
Let's dive into why a graph database is the secret sauce here. Why can't we just use a standard relational SQL database with rows and columns?
Relational databases are fantastic for many things,
Right.
but they are terrible at mapping complex, multi-layered human relationships and hierarchies.
They get messy.
Very messy. When you try to map a modern org chart in SQL, you end up with massive, slow, complex join tables that break easily. A graph model is entirely different. Think of it less like a spreadsheet and more like a social network map for your company.
So instead of tables and rows, everything is a node.
Exactly. In a graph database like Neo4j, every entity is a node. Alice Smith is a node. The senior backend engineer role is a node.
The production database is a node.
The ISO 27001 compliance framework is a node, and the connections between them are called edges. These edges clearly define the relationships.
Give me an example of an edge.
So an edge might say Alice Smith occupies the engineering role, and another edge says the engineering role has access to the production database, and another says the engineering role is governed by the MFA policy node.
You are building a digital twin.
A perfect replica.
A perfect, dynamic, virtual replica of the entire organization's nervous system. Because it is a graph model, you can traverse it visually. If you want to know what happens if you take a specific compliance server offline, you select that node, and the graph instantly highlights every single person, role, and policy connected to it.
You see the blast radius immediately.
The digital twin concept provides the ultimate organizational visibility. But we still have that practical UI hurdle. How does HR interact with this graph?
The solution is creating a translation layer. We build user-friendly interfaces that sit on top of the underlying code. We use the same extraction principles that make modern SaaS tools easy to use today.
Okay, walk me through what that looks like for the user.
So an HR manager logs into a web dashboard that looks just like any modern HR tool. They want to move a direct report from one manager to another. They click on the employee's profile picture and drag it over to the new manager's team in the visual interface.
Drag and drop.
It takes 2 seconds.
But behind the scenes, that drag and drop action isn't just updating a visual chart.
Not at all.
It is making an API call that automatically writes the new declarative YAML code, commits it to the company repository, and triggers the CI/CD pipeline to update the graph database and provision the new access rights.
The human interacts with a friendly interface, and the interface writes the code. The compliance officer who needs to update a security policy just fills out a standard web form.
They don't see any code.
They don't see a single line of YAML. But their form submission alters the core declarative state of the company.
This preserves the absolute integrity of the single source of truth, the code base, while simultaneously providing interfaces that democratize access.
It empowers everyone.
The HR team restructures departments, the security team updates compliance, and executives run sandbox models, all without knowing how to code. It feels completely natural, but it is backed by industrial-strength programmatic logic.
Which leads us to the final and perhaps most pressing question. Is this actually a buildable future, or is it just theoretical architecture? This is something a company can actually deploy today.
The conclusion from Rothman's industry analysis is incredibly optimistic. The technology is completely viable today.
It's already here.
We are not waiting on a futuristic scientific breakthrough. Every piece of the puzzle already exists in the enterprise ecosystem.
Absolutely. The components are mature. We have massive graph databases like Neo4j. We have robust declarative languages like HashiCorp's configuration language. We have identity providers with rich APIs like Okta and Auth.
The tools are ready.
The technological barrier to entry has already been cleared by the software engineering discipline.
The challenge isn't technical, it's cultural. The real question is practicality and adoption.
Will people actually do it?
Right. What will it actually take for a massive legacy enterprise, deeply entrenched in its island of static PDFs and clunky Workday instances, to throw away the paper maps and adopt the live GPS?
It requires vision.
It requires leadership to fundamentally change how they view the nature of their organization. You have to stop viewing your company as a collection of people managed by documents and start viewing it as an interconnected programmatic system managed by code.
It is a monumental shift. But the pain of the document disconnect is becoming too severe.
It really is.
As regulatory frameworks grow more complex and security threats become more dynamic, the sheer cost of manually bridging the gap between static policies and operational reality will force companies to evolve.
They won't have a choice.
The pain of migrating to a company as code architecture will eventually be eclipsed by the pain of remaining on the lonely island.
The incredible new possibilities, instant mathematically provable audits, zero trust security enforced at the architectural level, risk-free sandbox testing for corporate reorgs are just too massive to ignore.
It's the future of work.
The technology is sitting right there. It is just waiting for the right companies to start building the future. Okay, we have covered a massive amount of ground today, diving deep into the technical architecture of this paradigm shift.
We covered a lot.
Let's rapid-fire summarize the absolute bottom line for you. Maintaining our TLDR mission. Here are the 3 most critical takeaways you need to remember from this deep dive.
Number 1.
Takeaway number 1, the problem. The document disconnect is a massive, expensive drain on your productivity. Right now, vital company structures and compliance policies are trapped in static, unqueryable formats. This disconnect costs companies massive amounts of highly skilled engineering hours during security audits because the data is isolated from real-time operational reality.
Moving on to number 2.
Takeaway number 2, the solution. Company as Code fixes this by creating a living, queryable, version-controlled digital twin of your organization. By using a declarative language, you establish a single source of truth that defines your company's structure programmatically, allowing you to test organizational changes in a safe sandbox before deploying them.
And finally, number 3.
Takeaway number 3, the impact. This architecture fundamentally transforms enterprise security and compliance. By hard-coding internal policies and mapping them directly to frameworks like ISO 27001, compliance is enforced continuously by the system's pipeline. And crucially, abstraction layers and drag-and-drop interfaces allow non-engineers in HR and leadership to manage the system naturally while generating the underlying code behind the scenes.
That really sums it up perfectly.
That is the bottom line on a company as code. Before we wrap up, a quick reminder to all of you listening, if you want more deep dive analysis of the industry's biggest shifts, make sure to check out the Tech News TLDR YouTube channel for our daily video updates. We are constantly breaking down the complex news you need to stay ahead of the curve.
It is a phenomenal resource for staying informed. And as we close out today's discussion, I want to leave you with one final, deeply analytical thought to ponder on your own.
Okay, let's hear it.
This raises an important question about the long-term reality of this architecture. We have discussed the elegance of capturing a single company's entire structure within a strictly codified graph model.
Right.
But what happens during a massive corporate merger or acquisition? If 2 distinct enterprise companies, each with their own unique company as code architecture, their own declarative languages, and their own rigid policy nodes, decide to merge, how do you reconcile that?
That sounds like a nightmare.
Do you literally have to compile 2 vastly different company code bases together? And more importantly, when the nuances of human corporate culture are reduced to programmatic rules, how does a software system resolve a merge conflict of human culture? It is a fascinating dilemma that organizational engineers will have to solve very soon.